the relativity of velocity. Now, when objects move at speeds close to the speed of light, c, then the relativity of velocity comes into play. Now, according to postulate 2 of special relativity, the speed of light in a vacuum is always c, regardless of the motion of the source or the observer. Now, looking at an example. So, let's say we have a spaceship. Okay? We'll call this spaceship B, object B. And on this spaceship is a flashlight. Okay, we'll call this flashlight object C. And then finally, let's say you're an observer in the distance, very far away from the airplane. And oh, I'm sorry, we're going to call this object A. And the observer is object C. My apologies. Now, since this is a flashlight, the speed of object A is going to be c. Okay, so object A, so velocity of object A relative to object B is going to be c. Okay, so velocity of object A relative to object B. Alright, now velocity of object B relative to c. Let's say this spaceship is traveling at the speed or half the speed of light. So u would equal half of c. Okay, velocity of object B relative to object C. Okay, and then finally we have object C. Let's say object C is at rest. Now, we have this flashlight shining at the speed of light, and it's sitting on an airplane that's traveling at half the speed of light. Now, you would think, oh, I should just add these two velocities up to figure out the velocity of the light relative to the observer. Well, this is not the case. Remember, according to postulate 2, all forms of light travel at the speed of light regardless of the motion of the source or the observer. The equation here we have here gives us the actual relativity, the actual velocity of object A relative to object C according to the theory of special relativity. So if we were going ahead to plug in all these numbers, so v prime is the velocity of object A, so the flashlight, relative to C, the observer. So if we were to go ahead to plug in all these numbers, we would get u is 1/2 of C plus C over 1 plus 1/2 C times C over C squared. And when we go ahead and evaluate this expression, we get C. So the velocity of object A relative to object C is the velocity of light in a vacuum, regardless of the motion of the source or the observer.